So hello there. I guess we're just going to continue playing with the embedded stuff in Rust. So far we got the LED flashing working, the embedded equivalent of the Hello World. We configured the basic peripherals and managed to periodically turn the LED on and off. So now I want to try out the PWM functionality, the PWM peripheral on the STM. So just had a quick look here at the API provided. API for the STM32f1 crate that allows us to, well, basically to use the peripherals on the chip that we're using, and we're using the Blue Pill development board. So yeah, let's just start cracking. And so we're gonna have a look at the example, PWM example. And just start from there. So yeah, basically what I want to use for the PWM output is the PA15. Which is kinda handy. It uses the timer 2 to drive the timing functionality. It's a channel 1. So the only complication in here is that this pin is by default configured as the debugger pin, a JTAG debugger. So basically every pin on the STM microcontrollers comes with some predefined function. So and it takes that function on the second you power up, well, not the second, but once you powered up the STM. So for example, some of the pins, they actually come with a predefined function, so that for example you can upload the firmware into it straight after the boot, stuff like that. Which is very handy. This only complicates things when you want to use those pins as something else. So that means that basically you need to reconfigure it during your initialization procedure. So this pin comes configured as the JTAG port, so we need to disable it first. So we are going to copy the PWM example. There. Set period, blah blah blah. Okay. And we start cracking. So yeah, it's using timer 2 as we want it. We need to provide it with the timer 2 handle, which comes from the peripherals, device peripherals. It needs a reference to the clock configuration that we created in here, and the APB rail. We going to have to, so in the example here they're using pins that are just ready, PA1, PA0, PA2. So those pins, they're ready to be configured, but as we mentioned, the pin 15 comes as a JTAG port, so we're going to have to remap it. We're going to have to remap it. and to check what we need to remap it as, we can consult the documentation. So we need team2 partial remap. So let's just import it. So it's team2 partial remap 1. Okay. Yeah. Partial. Okay. Yes, we need to use the alternate function IO control register. And that's one of the peripherals. RCC APP1. And that's a mutable reference. APP2 in fact. Okay. And yes, so that's that. And the other thing is that we need to configure the pins as well. We need to disable the debugging functionality on it. So for that we need to yeah, actually yes, because it returns the tuple, because there's multiple ports on it. So actually let's have a look at the example, because they kindly provided us one there. That's the actual use case that we want to use. So AFIO and disable the JTAG. And you need to specify all 3 pins that are coming predefined as the debugger. So they also PB3 and PB4, and you can confirm that by looking at the documentation. It's this and this. But we are only interested in PA15, and we're not interested in the remaining 2. Whoa. And that's mapper and disable JTAG. And we need to move the pins into this function. I'm kind of going a little bit chaotic here, but we need to configure the GPO A. And we need to configure the GPO B port as well. And PA15. GPOB and GPOB. Boom. So now we need to configure the pins. So right now we disabled the JTAG. So what we're getting from here is a PA15 port configured as floating. as input floating point. And there's a method implemented for this type of pin. That will allow us to turn it into its alternate function. So PA15 into push-pull output, and we need CRH register, which exists in the GPOA struct, essentially object. It's a control register high. All of this can be mapped or matched or confirmed against the data sheets. That's a notable reference. There it is. So as you can see here, we just configured the port directly. Here we needed that extra step where we disabled the JTAG first. And actually, the Rust is so nice that it wouldn't let us even configure it as the push-pull output because of its type system. So if we were to try configure the PWM pin directly, so GPOA.PA15, there, we can see that it's actually configured as the debugger by default. Yeah, but if we were to configure it into push-pull output straight away, the compiler would warn us against it, or prevent us even from doing so, which is extremely handy, because otherwise you're spending days trying to figure out why your code doesn't work. Yeah. Okay, so now that we have the pin configured, we can use it as well, we can tell the PWM method to use this as one of the PWM pins. And what's going on here? Ah, yes, because it's not push-pull output. This is alternate push-pull. And it does not need to be immutable because we only use it to remove the debugging configuration. Okay, and we have this. So now what we can do is let's observe the pin. So let's set a couple of different duty cycles. C1 get max duty. So let's see how the quarter of the duty cycle looks like. yeah, so how does a quarter looks like? A half and a 0. Or, whoa, that would be not good. We don't want to reach infinity anywhere. And we need to import the channel. And actually, in order to register it, let's put it into the loop. Okay. So that should be fine, I guess. That should be compiling now. Let's load it. Boom. Okay, and so we know that that works because the LED is flashing. So we know that the loop is executed, which is a good sign. And we're just gonna try to observe the pin. I have a logic analyzer in here, so we will just hook it up. So we need a ground and we need a channel 0 to A15. So this is running. So this is a logic analyzer. We need to hook it up. The device. Boom. Okay. And I guess let's just run it and see what's gonna happen. Ooh. Timeout. That's interesting. A timeout. Okay, I guess that I also have the OpenOCD hooked into the USB and stuff like that, so maybe maybe it's just trying to read too much stuff from the USB. Okay, that's better. But still, Okay, this is pretty unfortunate. What's going on here? Let's try to restart it. Capture error action. Okay, this is very, very bad. Could this be better? Hide this channel. This is configured as trigger. Okay, so there. So actually, let's configure it as trigger, and let's check. So that means that there is just nothing in there. Okay, so let's hook it up to the LED, because we know that LED is definitely working, and we should see a state change, and the LED is connected to the PC13. This is ground. PC13, okay. So boom, there's a trigger. That's where the LED comes on. So that means that our PWM doesn't work. So let's have a look. So we configure the timer 2, PWM, APB rail, partial remap, the pin itself, so I just need to check our messages. Yeah, so we have the pin in here, and so what are we missing? Examples. GPO A, PA0, PA1, PA2. They use the 3 pins in here, but that's absolutely shouldn't matter. So set period, set duty. So we're basically doing the same thing. Okay, so they split the PWM into separate channels in here, but we don't have to. That's a different PWM channel. Okay, so let's have a look at the actual source. So channel. So implement pin. So this is where they implement the pins trait. The pins trait that comes from the actual embedded hole. Is it? No, they define it here. So you can use a single pin. You can use different combinations of those. So everything that implements pins, so that's fine. PWM channels. So PWM channel. So okay, that comes from the embedded hole definitely. So they implement it into the PWM. Whoa. Enable. No, what I'm doing, we're looking for example. They don't enable it. CCER. So CC enable. Select rising edge polarity. Enable capture. Okay, let's see the actual register. What does it do? What is it for? Well, there it is. First channel configured as output. OC1 signal is output and the corresponding output between. So that enables it. So we need to run enable. And I should have done it straight away then. Channel C1. Okay, so because that changed the type of it. Ah, yes, so we cannot do it like this. Oops. We just need to do it in here. There it is, and then channel. Oops. Channel C1. There it is. Will that work? That's and A15. Boom. So let's get rid of this and let's just capture it for a while, and we should see the changes in the duty cycle. What's going on? Let's channel 1. We don't want any trigger. configure the samples. No. There should be like a resolution where we can check it. No, that's only. So it captures it. How do I check the time or change the time domain on it? Start collecting data. There it is. That should collect way more now. Well, it didn't. There it is. Because we only doing this seconds. Let's say 10 seconds. Okay. So there was this time where the LED was flashing and waiting. So this is the 1/4 or the quarter duty cycle. Then it should change after a second. Come on. That's going to be a... there it is. There's somebody there. Okay. And then the 0 duty cycle somewhere here. So we know that this works then. Okay. So I guess, because my family just came back from the walk, I think it's a good enough place to stop it. And I think we get back to it maybe later on today. Okay, bye bye.